Okay, so this is AP problem number 6, and the question is, after a 1 mole sample of HI gas is placed into an evacuated 1 liter container at 700 Kelvin, the reaction represented above occurs and the concentration of HI gas as a function of time is shown below in that graph. So for part A, we had to write the equilibrium expression, or the K for the problem, and that's right here, so H2 times I2 divided by HI squared. And for part B, we had to say what is HI at equilibrium. So from the graph right here, we see that at equilibrium, or where the line is straight on the top curve, it's at 0.80, so HI at equilibrium is 0.80 molarity. Part C is asking to determine the equilibrium concentrations of H2 and I2, so I did an icebox, and so yeah, I got that H2 and I2 were both 0.10 molarity. On part D, we had to, on the graph, make a sketch that shows the concentration of H2 changes as a function on time. So I wrote down some descriptions, but it's also this blue line right here. So it starts at 0 molarity, increases to 0.1 molarity, and reaches equilibrium at the same time that HI reaches equilibrium, so it's that blue line on the bottom. And then in part E, we had to calculate the value of the equilibrium constants at 700 K, and for part 1 we had to do the equilibrium constant, and so, or the Kc, and that was, after plugging that in, I got 0.016. And then for part 2 we had to find Kp, so Kp is equal to Kc, which is 0.016, and that's because the moles of the products are equal to the moles of the reactants. So I know this because Kp is equal to Kc times RT to the delta N, and delta N is 2 minus 2, which are the coefficients of moles in the equation that we're given. So it's pretty much Kp is equal to Kc. And then for the last part, it says at 1000 K, the value of Kc for the reaction is 2.6 times 10 to the negative 2. In an experiment, 0.75 moles of HI gas, 0.1 mole of H2 gas, and 0.5 mole of I2 gas are placed in a 1 liter container and allowed to reach equilibrium at 1000 K. Determine whether the equilibrium concentration of HI will be greater than, equal to, or less than the initial concentration of HI, and justify. So I plugged in the values for the Q, and I got that it was 8.9 times 10 to the negative 2, and it's saying that initially it's 2.6, or at equilibrium it's 2.6 times 10 to the negative 2, so Q is greater than Kc. So to get to equilibrium, the numerator has to decrease and the denominator must increase, so HI will increase. And that's the end of the problem.